notice, and this is the typical copyright. We continue with mathematics syllabus 2018. As of January 2026, this syllabus has not been revised, but there are plans to change the structure of the exam from 2028 and onwards, with a few pilot projects now being conducted in a few Caribbean countries. The syllabus itself remains unchanged. The main planned change to the CSEC level math exam is to split the exam into two parts. Format of the examination: there will be a paper 1 that will consist of 60 multiple choice questions from all sections of the syllabus as outlined below here. Then there will be a paper 2, which is a much longer paper, consisting of 10 compulsory structured questions based on all sections. Note the current exam schedule for paper 2, no choice, all sections will be tested for the current syllabus. I think I made a mistake. In some previous videos, I had said that there were choices, but there are no choices. What will happen when the exam is restructured is another matter. And then there is a paper 3. If you are in school, it's a school-based assessment. If you are not in school and you are taking this exam as a private candidate, there is an alternative to paper 031. As it relates to marks, here is paper 1 would carry 30% of your marks. That's a multiple choice. Paper 2, 50%. That's a structured. And paper 3, 20% of your final marks. Questions will be based on knowledge, comprehension. The various percentages are listed on the far right here. Knowledge 30%, comprehension 40%, and then reasoning, which would be 30%. Finally, out of 100%, schedule of videos. As you already know, sections 1, 2, and 3 have all been completed and published on YouTube in their entirety as of December 2024. All 51 of these videos have been published in their entirety on YouTube, the complete videos. Then sections 4, 5, and 6. Some of these videos have been published in their entirety on YouTube, the others only partially. Section 7, relation functions and graphs. 9 of these 27 videos have been published on YouTube in their entirety. And we are now at section 8, geometry and trigonometry. This is the first of 24 videos. And of course, after that, we still have to do sections 9, vectors and matrices. Please note this disclaimer down here. This schedule is just a projection, and it is not to be interpreted as a contract with anybody. Going back to section 1, all 33 of these videos have been published on YouTube in their entirety, especially since they form the foundation on which the rest of the syllabus is based. A reminder, you need to know the times tables from 2 to 12, especially since calculators are not allowed in paper 1. Revisiting section 1, some of these videos are even applicable in primary schools for students who could look at the videos on their own, teachers who could use them in the inverted classroom, and especially the parents who may think that they are not qualified to teach their children this type of work. For example, section 1, if I expand that box, notice what it says for video 6. Add, subtract, multiply, and divide whole numbers. That's work done in grade 3. And then add, subtract, multiply, and divide decimals, grade 4 work, fractions, grade 5 work, and so on in primary schools. So the parents could look at the videos with the children and then ask the children to explain it back to them, the parents, and so on. That's section 1 from the syllabus, which begins at grade 3 work. Section 2, consumer arithmetic. All 12 of these videos have been published on YouTube in their entirety. Section 3, sets. All 6 of these videos have been published on YouTube in their entirety. From section 4, measurement. Some of these have been published on YouTube in their entirety, the others only partially. If you need full access, please see directions in the description below to get full access to those videos that are only partially published on YouTube. Section 5, statistics, 18 videos. Some of these have been published on YouTube in their entirety, the others only partially. Again, if you need full access to these videos that are only partially published on YouTube, please see directions in the description below. Section 6, algebra, an area that lots of learners say they have difficulty with. In this case, 7 of these videos have been published on YouTube in their entirety, and the others only partially. Again, if you need full access to these videos that are only published partially on YouTube, please see directions in the description below. Section 7, relations, functions, and graphs. These videos have been published on YouTube in their entirety, the others only partially. Again, if you need full access to those videos that are only partially published on YouTube, please see directions in the description below. That takes us up to section 7. Before we go on, recall I said in the introductory video that you will need a good math textbook or maybe a set of 2, especially to get more practice questions. CSEC recommends these shown on the right here. From those, I will recommend these last 2, especially since they form a very good 2-volume set of math textbooks that is quite adequate for the current and the future proposed changes in the structure of the CSEC math exam. This is a picture of volume 1, Mathematics, a complete course with CXC questions by Raymond Tulsi, and this is a picture of volume 2. Please note this disclaimer down here. I get no financial or other benefits from the sale of these books. Also, as of late 2024, a website with AI interactivity has been made available free of cost that deals with past CSEC math questions only, specifically from paper 2. It is extremely important that you become familiar with how CSEC sets its questions for paper 2 and what will be considered good or correct answers to such questions. The URL for that website, I will show you the home page on the next slide, which is this. You will have to register first and then sign in. But remember, I said it is free. This is that URL again, and that URL will be in the description of this video below, so you can easily click on it and be redirected to this website. Also, this is a reminder that this formula sheet is provided for the CSEC math examination papers, all 3 of them. It is included in the syllabus if you have a full copy of the syllabus. But if not, there will be a link in the description below from where this formula sheet can be downloaded. This is the top part of that formula sheet, so you could see some of the formula clearly. And I am going to state the obvious here. You do not need to memorize these formulae on this formula sheet, as this sheet will be provided during the math examinations. And this is the below part of that same formula sheet. While you do not need to memorize these formulae, you do need to know when and how to use them. Section 8, which is where we are now, geometry and trigonometry. A brief overview of where we are and where we are going. This is a print screen of the first page from that section. Another print screen from the second page. Another print screen from the third page. Another print screen from the fourth page. Another print screen to the fifth page, which takes us to the end of this section. 17 objectives, which I have divided into 24 videos, as you see here. We are here. Objective 8.1, I have had to divide in 2 sections because it is too much for one video. So we begin at 8.1. And it says, explain concepts relating to geometry. So the first video here is the most important video that you need to have a foundation to do the rest of geometry and trigonometry. We have to talk about all of these things listed here. First of all, what is geometry? It is that branch of mathematics that studies the properties, measurements, and relationships of points, lines, angles, surfaces, and solids in space. It focuses on understanding shapes like triangles, circles, and cubes, and their positions. This word, geometry, originates from the Greek root meaning earth measurement. And we are told that geometry began in ancient Egypt. And then trigonometry is actually a branch of geometry, studying the relationships between the side lengths and angles of triangles, particularly right-angle triangles. And the word is derived from the Greek word for triangle, trigonon, and measure, metron. And it uses functions like sine, cosine, tangent to calculate unknown parts of a triangle. So when they said here geometry and the trigonometry, that's a redundancy because trigonometry is included in geometry. It's a part of geometry. So first of all, explain concepts relating to geometry. And these are the concepts we are going to do. This is too much for one video, so we will split it into 2 videos. And this part here on the top, we will do in one video, part A, and the other 4 we will do in part B. So let's get started. Objective 8_1, section A. We begin with points, lines, line segments, rays, and curves as the first part of section A. We begin with point, and this is a surprise. We check the glossary of your syllabus, and amazingly, the syllabus has no definition for point. P-I-E, pie graph, pie chart above that, polygon, polyhedral, polynomial, and so on. There is no definition here for point. So we will have to find that somewhere else. Now bear in mind that all these concepts that we are going to deal with, like lines and line segments and so on, they are all based on the point. So what exactly is a point? A point is a precise location in space or on a plane. Basically the same thing. It is not a thing, but a location. It is therefore extremely small and is therefore said to have no size or dimension. Its position is often indicated by a dot. Convention required by CSEC is a dot with a small circle around it, as you see here, a dot with a small circle around it, or in the case of graphs, an X. So those are the only 2 things we will use to plot points. So as I said, a point is a location. It is not a thing, and is therefore infinitely small and is said to have no size or dimension, but it has a position. So there is the point. The point is the dot in that circle. If we expand it, this big dot is not the point. It is still exactly in the middle there. That's the point. If we expand it bigger, this bigger dot apparently is not the point. It is still just one little location in there, in there. And if we expand it even bigger, that previous dot, which is this now, is not the point. It is a location within there, just a location within there. And this is why you're not to use a fat so-called dot in plotting graphs and marking points. It's a position. Now, let us say we have this point here, and we will call it B, with a whole lot of other points to the right of it. You could see that we are beginning to have something like a line. If we have other points to the left of it, we can see like a dotted line there. Now, what about if we have some more points in between those points? Now, you can see we are approaching a line, but it's not quite a line. It is called a dotted line, but it's not really a line. So what about if we have like hundreds of points between all of those adjacent points? Then we get something like this. At this point, excuse the pun, we now have a line. Well, actually, it is not a line. If we extend those right to the far right to infinity and to the far left to infinity, and we identify two positions on the line, now we have the line PQ, but it extends forever to the right and forever to the left. A line is a geometrical object that is straight, infinitely long, and infinitely thin. So really, you have an infinite number of points located on opposite side of an original point, and those points are very close to each other. Now, in reality, it is impossible to draw a line because it is infinitely long and infinitely thin. And yet you are told to draw a line. And in a little while, I will tell you about drawing a line. We really cannot draw a line. Now, if we take part of a line like that, and we name the two ends P and Q, what we have is a line segment. So most of the time, when you are told to draw a line, you're actually told to draw a line segment. It is part of a straight line clearly identified by two stated points. So a line segment, and this is from your syllabus now, is a piece of a line with two end points. So far, we have talked about points, lines, line segments. Now let's talk about rays. If you consider the beginning of part of a line and you extend it outwards to eternity, to infinity, what you have there is a ray. A ray is a straight line extended indefinitely from a point called its origin. So this is a ray, not a line segment. And this is from your syllabus. A ray is a straight line that begins at a point and continues outward in one direction forever. Now, for convenience, the line PQ, the line segment PQ, the ray PQ, and the length of the line segment PQ are all written simply as PQ, as you see down here, which may be 8.5 centimeters. Now let's talk about curves. A curve is an object similar to a line that is not straight. That is not straight. Sometimes a line is considered a curve with zero curvature. A line which gradually deviates from being straight for some or all of its length is called a curve, as you can see here. And the best known curve we know is the circle. And so that takes care of this first subsection of part A. Points, lines, line segments, rays, and curves. If you find this video useful and interesting, please like and share. That is, like and share. You may also consider subscribing to this channel. So we are now here. Let's begin with parallel lines. Consider these two lines you see here, or these line segments to be more specific. If we take corresponding points opposite them and we put a set square and we measure the distance and we get a certain distance, whatever it is, and we take two other points here and we measure the distance and we get the same distance, and we take two other points here, E and F, and we measure the distance straight across and we get the same distance, then you can see as we move from left to right, the lines are not getting farther from each other, neither are they getting closer to each other. So two lines are said to be parallel to each other if they retain the same perpendicular distance between them throughout their length. Your syllabus states it differently. Given distinct lines in the plane that are infinite in both directions, the lines are parallel if they never meet. Or you could say that differently. Two distinct lines in the coordinate plane are parallel if and only if they have the same slope. But we already talked about that in algebra. Let's talk about intersecting lines now. You have these two lines, BA and BC. If we readjust them so that B connects at this point, then those two lines are said to intersect, they meet. Or if they cross each other at this point, we say that the two lines intersect. Two lines are said to intersect when they touch or cross each other. Now let's talk about perpendicular lines. Let's consider these two lines and let's adjust that one above there so it is standing upright and touching BC. So we get something like this. This is BC going across, and this is AD coming straight down, touching at D. If we take a set square and put it there, we will find that this angle here is exactly 90 degrees. So two lines are said to be perpendicular to each other when they intersect at an angle of exactly 90 degrees. That is at right angles. Those are perpendicular lines. Now we said that a line is an infinite number of points located on opposite sides of an original point and very close to each other. That's one way to look at it. So let's say that is our line. But what happens if we take an infinite number of lines and put them in that direction? Infinite. And then we put an infinite number of lines in this direction. What do we have? We have a plane. It is an abstract surface which has infinite width and length, zero thickness, and zero curvature. Remember I said all of these concepts are based on the idea of a point. Or a plane is an infinite number of lines located on opposite sides of an original line very close to each other. So you have a plane. So we just finished this: parallel lines, intersecting lines, perpendicular lines, and planes. Now for this video, we have to do this part here more. What are angles, units of measurements of angles, and types of angles? So you have seen this before. If you find this video useful or interesting, please like and share. Like and share, and you may even consider subscribing to this channel. So what are angles? Now consider a large clock face like what you have here, and you are standing at this point. You are standing there. You take both your hands and you point to the 12 o'clock position. Let's use a single red arrow to represent that direction. That direction is normally considered north, and it is designated as 0 degrees. Now, if you rotate a little with your hand still pointing in front of you, but now we will use a blue line We will still keep that red arrow there. So we will use this blue line. You will rotate a little to the right, and your arms are now pointing in this direction. As you gradually rotate from 12 to 1, you would have changed directions little by little 30 times. 3, 0. Each of that direction is called a degree. If you keep doing that until you go to 2, remember, you are rotating this way. You are turning your body that direction. To your right, now another 30 directions will give us a total of 60 different directions. So each direction is called a degree. It's not the space, it's the direction. And if you rotate another 30 degrees, you would reach the 3 o'clock position. And that position is called east, or 90 degrees, or quarter of a circle. As you could see here, that covers quarter of a circle. If we continue that rotation and we arrive here, you would have rotated that 90 plus this 90, 180 different directions. So you are now looking south 180 degrees. And if you keep that rotation to your right until you reach here, that will be another 90 degrees. So at this point, you are now facing west, and you would have rotated through 270 directions if you began looking at the 12 and you rotate gradually to your right. That's 90 and 90 and 90 more. That's 270 directions. Each direction is called a degree. And if you keep going a little more until you reach here, that will be 45 more degrees. And if you keep rotating a little more until you reach back where you began, you would have rotated 360 directions. Each direction is called a degree. 360 degrees. So you are back to facing north. So here you have a complete circle, 360 degrees. Here you have part of the circle, which is less than 90 degrees. Here you have another one, which is more than 90, but less than 180. Because remember, that is 90. This is 180. This looks like somewhere here, that angle. And then if you consider this one, which is over here, it looks like more than 3/4 of the circle. If you make it look something like that, it looks like more than 3/4 of the circle. That with this out here, not in here. Now, one complete rotation, which is a circle, comprises of 360 degrees, written as 360 with a superscript O. Angles are formed at the point where two straight lines intersect. Now, types of angles, we have acute angle. These are between 0 and 90 degrees. Then you have right angle, which are exactly 90 degrees. You have obtuse angle, which is between 90 and 180 degrees. And you have straight angles, which are exactly 180 degrees. And then you have reflex angles, which are greater than 180 degrees. Now, the vertex of an angle is the point where the two sides of the angle intersect, or they meet. Now, if I ask you to measure that angle, what does it look like? That's a trick question. I have to put a little arc to say which angle I'm talking about, because really you have two angles here. You have this small one in here, and you have this big one. out here. Same thing applies for this. You have that small one in there and this bigger one out here. And the same thing applies to this, that small one in there and this bigger one out there. And then of course you have this one, and you could probably guess this one here is a right angle. And this one down here, you can see it's a straight line, but you're not seeing an angle, but we can probably guess this one is a straight angle, that one is a right angle. That seems funny, a straight angle. All right, so let's put some arcs to make sure we know which angle we are talking about. In this case, we are talking about the big angle outside. Now, if we put a cross here, like a big plus sign, so that one side of the plus lines up with one of these lines, like this, you could see if those two lines began together here, and we rotate that one, that's 90, 90, 90, and that looks like maybe 70. So that is certainly more than 180. So that first one there will be a reflex angle. Consider this one in here, not the one outside. This arc indicates which angle. That, of course, if you put that big plus in there, that cross here again, if those two lines were together and you shift the one on the top a little that way, it hasn't reached 90 degrees yet. So that is less than 90. That one will be an acute angle. This one here, this partial square here, means 90 degrees. So when you draw 90 degrees, instead of using a smooth arc, you use a partial square. And then this one in here, again, if we put that big plus there, that cross here, to line up with one of these, and we assume that those two lines work together, and we gradually rotate this one like that, that's 90 and a little more. So that will be more than 90, but it hasn't reached 180. So that will be an obtuse angle, this angle here. Well, we could use a different cross here. We could use it like this. Now, assuming that these two lines were together, that one and this one, and now you're moving in this direction. You are rotating this line in that direction. Same thing, 90 degrees plus some more. It still is an obtuse angle. This one down here, now we could see it's a straight angle. That seems kind of funny. You think angle is something that is bent. So it is a straight angle if you put that cross here there. So those are the types of angles. There are 5 types of angles. There are 5 types of angles. This one would be a reflex, greater than 180. This one here will be an acute, less than 90. This one here will be a right angle. That one will be an obtuse angle between 90 and 180. Either way you look at it. And this one here will be a straight angle. Now, how do you measure angles? Actually measure angles. You use something called a protractor, which looks like this. I'm sure you have seen that before. Its sensitivity is 1 degree. Remember I told you about that direction. If you look closely, and you're counting from 60 coming this way, that will be 61, 62, 63, 64, 65, 66, 67, 68, 69, 70. The sensitivity is 1 degree. This is a different and bigger protractor. Normally you wouldn't be using such a protractor. But you look at this protractor now, if that is 10, this is 20, that will be 15, that will be 11, 12, 13, 14, 15, which means that this protractor has a sensitivity of 0.5 of a degree. But you wouldn't normally be using such a protractor. As we look here, we could see acute angle less than 90 degrees, right angle exactly 90 degrees, obtuse angle between 90 and 180, reflex angle over on this side here, which would be greater than 180. Now, if a circle gets very big, example 10 kilometers, then each degrees markers get so far apart that each degree is divided into 60 equal parts called minutes. So remember I told you about those 360 directions? But if the circle is so big, you could divide the space between each direction into 60. And each of those smaller directions now will be called a minute. And to make matters worse, if the circle gets even bigger, say 100 kilometers, then even the minutes markers get so far apart, the direction, that each minute can be further subdivided into 60 equal parts, and each part is now called a second. And sometimes you would see the direction written like this: 165 degrees, 45 minutes, 15 seconds, like that. Now, do not confuse the minutes and seconds of time with minutes and seconds of direction or angles. Fortunately, CSEC does not require you to use minutes and seconds in angular measurements or calculations. So for CSEC, you don't have to bother about minutes and seconds. In this case, we'll probably just round that off to 166 degrees. Consider carefully this circle shown here. If you stand in the middle here and you face that direction, you are facing north, which is 0 degrees. If you gradually rotate yourself towards the right, you will be changing from north direction towards east. Halfway between north and east, you will be facing northeast. Before that, however, halfway between north and northeast, you will be facing north of northeast. If you keep rotating like that until you are facing this direction, that is east, you would have changed direction 90 times. Each direction is called a degree. Now let's consider this protractor here. This arrow is pointing north. Around this protractor, you have numbers written. I will add a pointer here. So now this red pointer and that blue one there, let's set them up as north together. Now if I gradually move this, if I gradually rotate this way, I would have changed direction from north to a few degrees east of north, and a few more directions, until at this point where you see that 10, I would have changed direction 10 times as I rotate from north going this way. If I keep doing that, at this point, I would have changed direction 30 times. Each direction is called a degree. Now later on we'll find that those directions can be further subdivided into minutes and those into seconds. But for now, we will work with degrees. If we keep rotating this way, at this point, we would have changed direction 60 times or 60 degrees. Notice between that arrow and this arrow, there is this small angle form here, which is an acute angle. It is less than 90. If I keep rotating like this until I reach 90, I am now facing east. That is fully quarter of a circle. So quarter of a circle is 90 degrees. So anything less than 90 degrees from here to here will be acute. Exactly 90 will be right angle, exactly 90. So if I go over 90, say 120, this angle here between that blue line and this red one is greater than 90. So that angle is called an obtuse angle. Keep rotating that. Still obtuse. 160. This angle here is between 90 and 180. It's between there. And if I keep going until I reach here, notice this red line forms a straight line with that blue one over there. And so rotating through 180 degrees will give us a straight angle. I know straight angle seems funny because an angle is supposed to be something bent. But that's our straight angle. So let's get this clear. Any angle less than 90 is acute. Exactly 90 is right. Between 90 and 180, any angle between here is obtuse. Now, if we go beyond the 180, if you go beyond that 180, like say 200 here, so that's one right angle, which is 90, a second right angle, which is 90 more, which is 180, and now we are 20 beyond the 180, so we are at 200. This angle here that passes 180 is called a reflex angle. If I keep rotating that until I reach here facing west, that would be three right angles. One here, as you can see, one down here, and one over here, which gives us 270 degrees. So it is more than 180. It is a reflex angle. If I keep going like that until I'm facing, say, northwest, halfway between north and west, if I'm facing that direction, notice this angle here is a reflex angle, but the other angle on this side is now an acute angle because that angle there is less than 90. And if I keep rotating this, changing directions, and I reach back over here, all the way around, I would have changed directions 360 times. Each direction is called a degree. Now, that's an easy way to think about it. And of course, if this protractor was much larger, let us say the circle is like 10 kilometers, then between 1 degree direction and the next degree direction, there will be many more directions I could find between there. So let us say I'm at 20 on this protractor, and there I am at 21. But if this circle is like 10 kilometers long, then the directions between 20 to 21, I could fit 60 more directions in there. And each of those little directions would be called a minute. And then if I make the circle much bigger, say 100 kilometers or 1,000 kilometers, then even between the minutes, there will be many more directions. I can further divide those into 60 equal parts, and each of those little parts of the minute would be called a second. Do not confuse that with minutes and seconds of time. So we just looked at angles, units of measurements, and types of angles. So part A of objective 1 in section 8 explained concepts relating to geometry, and we looked at a few concepts, these up here. In part B, we will deal with some others like number of faces, edges, and vertices of regular solid objects. So that brings us to the end of video 1 based on objective 1A in section 8.